Hi everyone, I'm Ariel. So today I'll be talking to you about my summer research, which was about the feasibility of harvesting energy from natural evaporation. So firstly, I'd like to thank Papa Jack because without his generous donation, none of us could have done our research today. And it also got me interested in doing my own research across the course of the year, so I'm really excited to see how that will go. So the problem I wanted to combat was the problem of global warming. As you know, this is definitely a very prevalent issue today because some of the impacts include ocean levels rising over 8 inches since 1880. There are higher concentration of carbon dioxide in the atmosphere, which makes the ocean more acidic, and therefore there are more animals that can't survive in such low pH. Spring arrives earlier, 10 days earlier on average, and there are more damaging wildfires. All of this information is taken from the link below. So some of the renewable energy sources that people have been looking at are solar, wind, waves, and geothermal heat. Solar and wind probably being the most common ones that you would know about. However, solar power is often rather costly, and and wind power is not really applicable to like household use. So only solar panels you would find at everybody's house. Not everybody's, but they are found at people's houses. So that's why I wanted to try find something that could work better on a more household basis and it could be more accessible to everyone. So what I was looking for was this source called natural evaporation. So why is natural evaporation so useful? First of all, in this paper, it said that it could supply over 60% of US energy per year as measured in 2015. And Hawaii is surrounded by all of these oceans, so I thought that if we could make use of salt water for natural evaporation, then we could implement it in Hawaii in the future. And it's not extremely costly, so it could be used in household conditions. Firstly, I had two research questions. The first one was, could natural evaporation generate energy? And does using salt water make a difference from using tap water? My hypothesis was, streaming potential can be utilized to generate energy from natural evaporation, which I will talk about in a second, and that using salt water would amplify the streaming potential and create a higher voltage. So some background information. Voltage is an electrical potential difference, which is the movement of charge and the movement of ions, and the current is the rate of the movement of ions. So traditional batteries rely on a chemical reaction which creates a buildup of electrons at the anode. Electrons will move to cathode and that will create a voltage and current. So what is streaming potential? As we can see in this little animation here, as water moves upward, it will take its positive ions that are attracted to the negative ions in the solid, which I used glass, and as it moves upward, those ions will move with it as well, and as it evaporates, those ions will go off, and so there will be this continuous movement, and that will create voltage. So for my device, I used this a glass sheet, and I covered it with activated carbon because activated carbon is really porous, so it provides a lot of surface area for net evaporation. And I drew a conductive path with a CircuitWorks conductive pen. So as you can see, one of it goes up the front and it goes up the back as well. And to prevent from any water exposure, I covered the parts that would be submerged underwater with tape and silicone glue. At the top, I added copper tape just so that would be easier to measure when I put the voltmeter on, and I added some tape just to make sure that didn't get any oxidization either. So how I measured this was I put this device in a cup, and it was half filled with water up until the blue line, and I would let it sit for 1 hour, 5 hours, 1 hour, 10 hours, and 20 hours, and I would measure the voltage at these different points in time. So I did find that salt water can generate electricity. So this is a scatter plot. I did about 10 trials. So I put them, even though they do look a little bit clumped together. So for average of 1 hour, it was approximately 33 millivolts. And for 10 hours, it was approximately 65 millivolts. And for 20 hours, it was 86. So in this, I put both the lines of the tap and salt water just to show the differences. As you can see, salt water is not that much more efficient because on average it was only about a millivolt or two higher. But what I did discover was that it was more stable because when I was measuring it with the voltmeter for tap water, it would often drop pretty quickly in like 10 to 30 seconds. But with salt water, it would stay a little bit more stable and only fluctuate about a few millivolts before dropping. So my conclusions are that it is feasible to use streaming potential to generate energy through natural evaporation, and saltwater does not create the voltage generated significantly, but stabilizes it. So for future research this year, in the summer, I did try a new method, which is using concentration gradients, and those did provide me with a lot better voltage. So this year I will be working on improving that voltage and figuring out the true basis of concentration gradients, because we're not entirely sure of the full reason why it is able to create energy. So for reflections and advice, I would say to make use of your time wisely, because even though you have a plan, sometimes you're not that organized and you can waste a little time at home. I also would suggest to stay organized with a lab journal, because it does really help if everything's in one place. And just like Andrew said, don't be dismayed when things don't work out, because that's what happens when you do research. So hopefully some of you will think about doing this next year. So some final acknowledgments. I'd like to thank Dr. Chan for her endless support this summer, and my mentor, Dr. Yu, and that's him with his son at the aquarium. So yeah, so I'm grateful for both of them providing me support and mentorship this summer. So here's the bibliography, and thank you for listening to my presentation.